Okay, in this presentation we're going to look at time series analysis. So we're just going to start off with a very simple data set. Well, it's a very well-known data set. It's actually contained in R and it's called air passengers. Okay, so what I'm using here is Azure notebooks and I'm using R, obviously. And so, well-known example of time series, and it is related to the growth in passenger numbers in the USA between, I think it's 1949 and 1960. Okay, so it's a very simple data set, and that's all we're looking for. So what I'm going to do here is call it. So it's actually inbuilt in R. So it's one of these data sets like Iris and so on that is comes pre-installed in R. Okay. So I'm just going to shorten the name and ap.timeseries, just actually ap.ts, just to shorten the name. And also to reflect the fact it's a time series. And I'm going to, like in a couple of the videos after this, I am going to put in a couple of these little subscripts just to sort of be clear about what each object is, okay? In R, that dot doesn't mean anything. It's not like other programming languages. That dot doesn't mean anything. It's just to sort of make it more legible. I can make a quick plot of this, okay? I'll just change that there. And what I'm going to do here is, this is just a very simple plot command. And let's have a look at it there. Just actually give us a sense of what we are dealing with here. So this is a little bit hard to tell on the page. So I'll just sort of move that up a little bit and see if I can make it a little bit more legible. Well, I think you get the idea there. It's just a sort of crop there at the bottom, but essentially it is there's the growth in airline numbers, airline passenger numbers between 1949 and 1960. Okay, so you can sort of see it sort of increases very steadily. Okay, but you can also see this sort of jagged effect. Okay, and that might be reflect, for example, seasonality. Okay, so essentially what we're looking at here, there's a couple of things. There's an overall trend; it's increasing. Okay, but there's also seasonality. Within each year, there seems to be a big dip and then a big peak. Okay, so that's trend and seasonality. Okay, and that makes sort of sense. Like you might sort of expect lots of people to go on their summer holidays in the summer and fly off somewhere, so that airlines are particularly busy in the summer, and then they might dip in the autumn, but there might be a bit of a bump at Christmas again, something like that. Okay. And what happens also is that over the course of the decade, airline travel increases and gets more and more popular. Okay, so I'll just let you have a quick look at that. It's a very simple command. Plot dot, just actually name the object. You can put a little label there, and then just some to make the plot a little bit easier to read. I'm going to comment that out. Okay. Now, something that you might be interested in is just actually the class of the object. That's always quite important. What exactly are you dealing with, okay? So if I was to run that, and also the structure command, which is also sort of handy, the class is the main one there, but str is structure, and so that's ts, time series object. Very important actually to sort of make that distinction or make that clear. And we have 144 144 items, okay, from 1949 to 1961. So that seemingly corresponds to a 12-year period where we have 12 months in 12 years is 144, and that's the passenger numbers for each month, okay? So we can get a sense of where they are. Okay, so the start and the end actually just tells us how this is just a sort of inbuilt object in these are some useful commands. So actually, they're sort of like exploratory commands just to sort of explore the data a little bit. And the start of our data set APTS is 1949-1, and intuitively that means January 1949, and it ends in December, which is 1960. Okay, and the frequency there is, the internal frequency for a period is 12. Okay, so those are just some useful commands. So that's actually very intuitive. 12 years, 12 months in a year, and so on. Okay, so what we can do here, actually, this is just plotted again. Okay, and what I'm going to do here, I have it done. So essentially, what something very similar to what I've done previously. I'm going to just actually sort of remark the trend there. Okay, that we sort of there's a trend going so that like what happens here is that the flights get more and more popular over the course of the decade. That's something I sort of mentioned already, so it just actually reinforces that, and we have this jaggedness here. Essentially what we want to do is see if we can decompose that a bit, okay? So we have that overall trend there. It's very evident. I think you can sort of agree that that sort of line through the data actually is very... it helps the explanation of what's going on. Just to be clear, actually, what is that? That's a sort of linear regression model. And you can LM air passengers explained by time air passengers. Okay, that's a sort of a little bit. That's a little bit of a cheat. I'm sort of putting in something I'm going to do later on there. Just actually use a regression mod to explain the time series data. It's not actually a proper analysis as such, but sometimes you can get the nice graphs because of doing this analysis. Okay, so come back to that later on. You can also use a ggplot2, but we're going to leave that for another time. Okay, ggplot2 is a very nice way of presenting graphics, but it takes a while to get the hang of the graphics, and you sort of wouldn't use it really for just a quick look at something, unless you had something made up already, some sort of function made up already. Anyway, because what I want to do is focus on this command here, decompose, okay? So essentially what we're going to do here is we're going to sort of remark that we have this observed data, okay, and it's made up of components, okay, a trend. So each observation can be explained by a couple of different things. An overall trend, so that the big increase in passenger numbers over the course of the decade. Seasonality, particular months where air travel is more important. And then random error, just to sort of account for random fluctuations, okay. Now, there's a couple of different models. I'm going to sort of focus on the second one there, called the multiplicative model, but there's a simple additive model, which is sort of mostly used for sort of pen and paper calculations. I just sort of put it in there. Anyway, the multiplicative one is the one I'm particularly interested in. So that is to say that the multiplicative model is that each observation is sort of explained by a trend point, a trend characteristic, a seasonality characteristic, and then also just a little bit of random error, okay? So how do we decompose the data? We have ap.ts, okay? And what I'm going to do there is decompose it, okay? So I'll actually just put in a little, I'll just break up the command a little bit, okay? So that we're not doing it all in one go. So decompose ap.ts and just say its type is multiplicative, okay? Just to sort of, we're going to sort of decompose it a bit and see, does this make sense, okay? Now, this is what happens when you decompose it. You get all the data there, okay? And for each point, it makes an estimate of the seasonality, the trend, okay? And so the seasonality there is just sort of trying to makes a guess as to when air travel is quite popular. And seemingly July and August it's quite popular. And December and January, a bit of a bump as well. And so on, okay? There is a trend component, so it just actually gives us sort of a sense of the overall growth in airline travel, okay? And so on. And random error, okay, residuals essentially, okay. So, that's a lot to take in there. So what I'm going to do is plot that instead, okay, because that's what we really need. We just want a general gist of it, okay. So what we can do actually is we can decompose, plot that data there, and decomposition of multiplicative time series. So this is the sort of the observations again, okay. And this is an estimate for the trend, this part here, okay. And we have seasonality just below that. Oops. And the random error, which should be, the random error just below that, okay. So, yeah, that's it. That's as far as I'm going to go with this video. So that's an important one there, decompose. And this object has to be a time series object, okay? and the type is multiplicative. Now, this is more or less an exploratory data analysis, actually having a look at this plot here and just to sort of get a sense of it. Because really what you should do there after the fact is there's a few more things you can do to really properly explain the model, but this is actually a great start. But I wouldn't rely on it solely, okay? So we'll leave it there.